What we're going to do now is to answer some limit problems, and we call this exercises on limits or limits exercise. And we have here some examples. Example number 1, we have the limit of logarithm of x squared to the base 5 as x approaches 5. And this is a limit problem or a limit exercise involving logarithms. We would rather call it that way because limit of logarithmic functions is a much more complicated process, and this is a very simple process. Now, by direct substitution, we have logarithm of 5 squared to the base 5. And this is equal to what? Now, according to the rule of logarithm, that says logarithm of a raised to n to the base a is equal to n. Now, by following this rule, we have a as 5 and n as 2. And the answer, and this is equivalent obviously to 2. Now, in simple words, we have, simplifying this, we have logarithm of 5 squared to the base 5 can be written as logarithm of 25 to the base 5. Now, what do we mean when we say logarithm? Logarithm is simply an exponent. And in simple words, we say, what is, or we ask, what is the exponent of 5 so that it becomes 25? Well, again, the answer is 2 because 5 squared is 25. Now, graphically, how does it look like? It looks like this. To answer, to understand the limit of this problem, we have this graph. And suppose this is the value approached by x as x approaches 5. The limit is 2. And this is what the graph of this function looks like. Now, for example number 2, we have the limit of square root of x plus 9 minus 3 over x as x approaches 0. By direct substitution, we get 0 plus 9 minus 3 over 0. Simplifying, we have square root of 9 minus 3 over 0. Now, square root of 9 is equal to 3, right? And 3 minus 3 gives us 0. And we have this for an answer. Now, this is an indeterminate form. So direct substitution will fail us. So what do we do? Now, solving this kind of limit problem, we need to multiply the numerator and the denominator by the conjugate of the numerator. What is the conjugate? Conjugate is conjugates are rather is a pair of binomials with opposite operations or operators. And what is the conjugate of the numerator? We rewrite this limit as x plus 9 square root of x plus 9 minus 3 over x as x approaches 0. Now, we again, as we have said, we multiply this whole fraction by the conjugate of the numerator. So, why do we do this? Because our goal is to remove the radical symbol from the numerator. Okay? Now, we have, and this is the conjugate, x plus 9 plus 3 over x plus 9 plus 3. Rewriting the whole limit, we have now this is going to become the difference of two squares, and when you square the square root of x plus 9, that gives us x plus 9. And if you square, if you multiply negative 3 by positive 3, that gives us a negative 9 over x times x plus 9 plus 3 as x approaches 0. Now, simplifying this further, we get limit of 9 minus 9 is 0. So we get x for the numerator. And then we have here the denominator, x plus 9 plus 3 as x approaches 0. Now, simplifying this, what do? We cancel x. So, we have the limit of 1 over square root of x plus 9 plus 3 as x approaches 0. Now, can we do the direct substitution? Now, let us try. 1 over square root of 0 plus 9 plus 3, and this gives us 1 over square root of 9 plus 3. Again, we have 1 over, what is the square root of 9? The square root of 9 is equal to 3. And so we had 3 plus 3 for the denominator. And the final answer would be 1 over, what is 3 plus 3? 6.